For lesson 9, we are still going to be looking at linear functions. This time we're going to be analyzing them. So for our first example, it says Wilson Middle School has money left over from last year's fundraiser. This year, students are selling discount cards for local businesses. The graph shows the leftover money and the amount the school will earn for each card sold. Write an equation that shows the total amount of money the school will have, including leftover money, and the amount earned selling X number of cards. So we have a couple of questions to answer here as we go through and figure out what our equation would be. So the first question is, what does X represent? And you can find that in two different spots. Spot number 1 is right here. It tells you X number of cards. And the other thing is looking over here at the graph. The x-axis is right here, and the x-axis is labeled number of cards sold. So there's actually two different spots that you could have figured that out from. And then what is the rate of change? Well, remember the rate of change is how far we're going to go up. It's our slope. So I'm just going to use these two dots right here. You could have picked any two that are on this line. And we have to go up and then we have to go over to get to the next dot. So it looks like I'm going up 20 according to the y-axis there. I'm going from 120 to 140. And then I'm going to go over. If I go down here and look at the x-axis, I'm going from 10 over to 20. So that's going over 10. So if I write rise over run, my rise was 20 and I went up, so it's positive. And my run, I went over 10 to the right, and going to the right is positive. And then I can simplify that down to 2 over 1, and 2 over 1 is 2. So what is my rate of change? Well, we're going up 2 for our every 1. So amount earned is on the y-axis, so 2 is your dollar. And then X going over on the 1 is the number of cards sold. So what is the rate of change? The rate of change is 2, and that means money per card. So it's $2 per card that they get to keep. What does the rate of change represent? I just answered that. I should have looked ahead. So the dollar per card. And then what is the initial value and what does it represent? Well, the initial value is, where does it start? It starts right here. So the initial value would be $100. And what does it represent? Well, it represents the money. It's on the y-axis, and the y-axis is amount earned. And if you remembered back when I first started reading the problem, it said they had money left over from last year's fundraiser. So 100 would represent where they started this fundraiser, so the money from last year. And then write an equation that shows the total amount of money the school will have after selling X cards. So we're going to start with y equals. And how much did they start with? They started with $100. And they're making money. They're making $2 per card. And we're going to say 2x because x represents the number of cards. They told us that in the problem. If I wanted to, I could flip this around. So it was y equals 2x plus 100, because that is in y equals mx plus b form. So that would be the equation for that problem. Now looking at these three graphs, they're asking us to find the slope. And the slope is rise over run, or rate of change. And we're just going to pick two dots. I'm going to pick this one here. It starts at 0, 0, and then there's not a perfect point here. So I'm going to go to the next one. It crosses at 2, 1. So I want to use that one. So I'm going to go up and over to get to that dot. And I have to go up 1, and I have to go over 2. So rise is 1, and the run is 2. For this one, it starts at 0, 0 as well, but it crosses right at the next line there at 1, 1. So I would go up 1 and I would go over 1. So that slope would be 1 over 1, which simplifies down to just 1. And then our last one, it's telling us to use these 2 points listed here. So 1, 2, and 2, 4. That means I'm going to go up and over. Up is 2 and over is 1. So 2 over 1, and 2 over 1 simplifies to 2. Now, the rise or the vertical change is the difference in your y values. And the run or the horizontal change is the difference in our x values. So there is a slope formula that we can use if we don't have a picture to actually figure out the rise and the run. And that formula is y2 minus y1 over x2 minus x1. And what that means is if you're given 2 ordered pairs, and ordered pairs are always in the form of xy, you're given 2 of them. The ones in the first point are your number 1s, and the x and y out of the second point are your number 2s. So I'll do a couple of examples here to show you that. But first, there's one more question. It says, what number will the x-coordinate always be in the ordered pair that identifies the y-intercept? So if I go back over here and look, the y-intercept here is 0, 0. The y-intercept here is 0, 0, and the same with that third one. But let's go back up and look at this graph. This y-intercept is at the ordered pair of 0, 100. So the question asked, what is the x-coordinate of all of the y-intercepts? Well, they're always 0 because you don't have to go over anything. You just have to go up or down to get to the y-intercept. So if you see an ordered pair that has 0 as the x, then whatever that y value is the y-intercept. All right, let's use the slope formula here. It says find the slope of the line that goes through the points 8, 3, and negative 2, 6. So we are going to use this formula. And remember, the first point are your number 1s, and the second point are your number 2s. So we're going to start off with the top. We're going to have y2 minus y1. So y out of our second point, remember they're always xy. So what's y out of my second point? It is 6. And we're minus, because that's what the formula says to do. Y out of my first point is 3. And then at the bottom, we're going to have x2 minus x1. Well, x out of my second point is negative 2 minus, because that's part of the formula. X out of my first point is 8. Now we simplify this down. 6 minus 3 on the top would be 3. And negative 2 minus 8 at the bottom would give us negative 10. So negative 3/10 is my slope. And we just write the negative sign at the top of our fraction. We don't need to leave it at the bottom. All right, and then one more. We're going to do the same thing. Y out of the second point would be negative 6. Minus y out of the first point would be 4. And x out of the second point is 3, minus x out of the first point is negative 1. So what I notice right off the bat is I have minus a negative at the bottom, so that really turns into a plus. 2 negatives in the middle make a plus. Minus a negative is the same thing as adding. So now let's simplify. Negative 6 minus 4 at the top would be negative 10, and 3 plus 1 at the bottom would be 4. And both of those numbers are even, so I'm going to cut them in half, negative 5, and then half of 4 would be 2. And that is my slope. So good news is we don't have to write these numbers proper because their slope, they're our rise over our run. we don't want to write this as -2 1/2. We want it 5/2 so that we know what our rise and our run is. All right, so for this next one, Tony's taxi charges $3 to pick up a passenger plus $2.50 for each mile. Write an equation for the function that relates the total cost of the trip to the distance. Also, identify the slope and the y-intercept of the function. So we want to write y equals, and let's go through and see what it charges. $3 to pick up a passenger, so you have to pay that $3. Then it says plus $2.50 for each mile. So plus 2.50, $2.50 for money for each mile. And we don't know how many miles they're going to go. So it could be 10, it could be 5, it could be 100. So we're going to put an X there because we really aren't sure. So now we have our equation, and I'm going to flip that around so it's in mx plus b form. And then it says identify the slope and the y-intercept. So y equals mx plus b. So remember, m is our slope. And if we look here, we have 2.50, or we could say 2.5 is our slope. It's in the m spot. And the b is the y-intercept. And in the b spot, we have a positive 3. All right, and then our last one says Elena is training for a bike race. She makes this graph to show the relationship between time and distance if she maintains her planned speed. Write an equation for the function, then identify the slope and the y-intercept and explain what each means in the context of the problem. So let's look here. We know we need it in the form y equals mx plus b because it is a linear graph. It's a straight line. So b is our y-intercept, and if we look at the graph, we're crossing the y-axis at 20, so we're going to have a plus 20 there. And then x is our slope, so we need to figure out what our slope is, what our rise over run is. So if I go from one dot to the next, and it doesn't matter which two dots I pick, I have to go down and over to get to it. So looking at the y-axis, I'm going from 15 to 10, so I'm going down 5 here. And then at the x-axis, it looks like I'm going from 20 to 40. So that means I'm going over 20. So my rise was down 5. So that's actually a negative 5 because I'm going down. And then I go right 20. So now we have to simplify that. So both of those can be divided by 5. So I would have a negative 1 over 4. That would be my slope. So there's my equation. Negative 1/4 is the slope. So we have to say what that means. Well, I'm going down 1. My y is distance from the finish. So 1 mile from the finish, or I'm going 1 mile, or I'm closer 1 mile to the finish line every 4 minutes. I shouldn't say going because that doesn't make sense. So I'm 1 mile closer to the finish here is what I really should say. Every 4 minutes. And then what does the 20 represent? The y-intercept. That ordered pair was over 0, so that means 0 minutes. I was 20 miles from the start line. So at the start, she had 20 miles to go. Or we could have said 20 miles was our starting distance.